Lecture 6. In this lecture, we'll learn the measures of variation. So measures of variation are range, variance, the standard deviation, and the coefficient of variation. Measure of variation or measures of dispersion. So we will learn this one now. Measures of dispersion are single numbers that are designed to tell us how the scores are dispersed or spread around the mean. So dispersion or variation means tashattat here. So we have a data set. Let's say, okay, I will show you what we mean by spread or dispersion here. Data is, let's say, 53, 55, and then 52, and then let's say 56, and then there's this 54, let's say. Now look at this data set, and you can put here some more. Okay, this is enough. This mean, when you calculate the mean here, the mean will be 54. And now let's see the spread of the data here. To show this one, I will just make the mean here. The mean is 54, level 54. And then the other data points, I will say, okay, let's say this is data 1. Let's say this is 53, so I will put 53 here. And then for this is not frequency table, by the frequency graph. Okay, just data 2 is this 55, and then 52 is again here somewhere here 52. This was 53. This is 55. Then this is 52, and then the 56 is here, and then 54 is here. So you see how spread data is from the mean. Sometimes it happens that your mean is here, your data is very closely spread out from the mean, or it might be very far from the mean. These are all about dispersion or variation. So we will try to measure the variation in different ways. Now, to measure the spread of the data or the variation, the measures of variation, we have three things at hand. This is range, variance, or standard variance, and standard deviation, and the coefficient of variation. These are the four tools we use for the measures of variation. Now let's start with the range. So range means the difference between the highest and the lowest values in the data set. So it's just basically telling you kind of the length of the data set. So here is the formula. The range is equal to the highest value minus the lowest value. Now look at this data. Okay, this data gives the average monthly temperatures recorded in a city in 10 months. So find the range of the data. So you find the highest value, and you look at here. The highest value is 35, 38, and the lowest is -6. So you subtract 38 minus 6. It has to be 44. If we have data which is given in terms of classes at group data, how can we calculate the range? So it says find the range for this group data below. So in this case, since the data values we don't know, just we know the classes only, so you will find the highest boundary, highest class limit 74, and the lowest class limit is 45. Then you subtract them, and you will get the range of the data, which is 29 here. And you can say here the weights are spread over the interval length of equal to length of 29 kilograms. Now let's look at the variance and the standard deviation. Let's start with the variance. The variance is the average of the squares of the distances of the data values from the mean Now, what does this mean? Let me tell you. You have a data set. Let's say data set. Let's say this is 49 and 50, then 53, and then you have 54. Let's say. Now, if you calculate the mean here, it's 51.5. And let's put this data values here. Let's say this is not a frequency graph, by the way. This is just I'm trying to show you the dispersion of the data. So I'm putting them this way. Data for this is 50, 49 is here. Let's say 49. So you have this 49, and then 50 is let's say here. Then we have 53, and then 54 is a little higher. And now, if you look at the mean here, the mean is somewhere here. It's the 51.5. I'll draw a line. So here, look at the distances between 49 and 51.5. Look at the distances of the data values from the mean. So these are the distances. Oh, okay, I will put them here. So you look at the distances. You take their squares and then add all of them, and you divide by 4 because you have 4 data values. So this gives you the variance. So the variance is like calculating the average distance squares. Now, where do we use this? Why it's that important? Because of the standard deviation. And the standard deviation is the square root of the variance. So basically, we take the square of the variance, and we get, okay, this is very, very important here all the time. Standard deviation is equal to the square root of the variance. So keep in mind always. And what does this mean? It brings, okay, it gives the meaning standard deviation as we can take the meaning of standard deviation in this case is it shows approximately how much in average data values deviate from the mean. So it's like we looked at the distances. Basically, it says like in average, what's the distance? So it kind of answers the question like the what's the distance of the data values to the mean in average. So, for example, your standard deviation is very small. What happens? So you look at here, your mean is here. So the average distance is very small. It means your data values are very, it means they're very close to the mean. So if the standard deviation is small, you have this type of distribution. Okay, there will be always some big or smaller values. Now, if the standard deviation is big, so the data values around the mean will spread more. So then when you calculate the average distance, you will have a bigger strip here. So, okay, let's state this one. Okay, let's state this one as a fact. So what does it do? So it says if the standard deviation is small, this means the data values are fairly concentrated around the mean, and the standard deviation is high. The values are more dispersed around the mean. So you can keep in your mind. So the data values are this in the mean very close to. Mostly they're close to. There might be some others here, but they're mostly close to the mean. And if the standard deviation is small, and if it's high, it means you have this mean here, but the data values are mostly further from the mean. They have bigger distances. Now, this calculating the variance and the standard deviation requires lots of calculation because you are looking at the distances, squares, and taking the average, then taking the square root again. Now here is you see a list of the formulas for the variance. So look at here. If we have a raw data, then if it's a population, then we calculate it this way. And we always write the variance for the population variance as sigma squared. And the sample, for the sample variance, we use s squared. And it has the same formula almost, except n minus 1 here. And this one here, it can be written as, I mean, in this form, n times the sum of the x squares and minus the square of the sum of the x values or data values divided by n times n minus 1. And for the grouped data, if we are given group data, it means like you have classes here, with like 1 to 10, 11 to 20, if you have this type of thing, then you calculate the variance by using the frequencies and the midpoints. And the formula for this one is that if this is the variance, the standard deviation is always the square root of the variance. Yeah, it might be population or the sample or the group data. It doesn't matter because you always take the square root of the variance. So one thing is here, this sigma symbol, use it when you see it, you will understand this is for population. When you see S, this is for the sample standard deviation. And for the group data, we always use S. I mean, we use S here. Now the population variance and standard deviation. Here, as I told you, the formula is sigma squared, which means the population variance. This is the notation for it. And it looks at the distances. Okay, x minus mu makes the distance from the mean, and then take the square, distance squared, divide it, and get the sum divided by n. Now the population standard deviation, you use the same formula except you take the square root of the variance, and here the population standard deviation, it's shown by sigma. Okay, now let's do an example. The following data gives the number of hours slept per day by 10 people, and assume this is your population, and find the population variance and the standard deviation. Now, the first thing you have to do is you have to find the mean. Okay, find the population mean. So here is how to find the average or the mean. You add all of them, divide by the number of the values, which is 10, so it will be 5.8. And then after this, it's better you make a table, so you put all the x values, the data values, and then mu, it's same for all of them. And then you subtract these two, and then you will get 1.2, and then you subtract 6 minus 1.5, 1.8, it will be again 0.2, and do the same thing for all of them. Sometimes you get minus values, sometimes positive values, but it doesn't matter because you will take the square of them, like 1.2 squared, so this is 1.44, so this will be 0.04. Okay, it has to be 0.04. This is 0.04, which is 0.2 squared. Okay, 2.2 squared, again, what is this? This is 4 point something. Okay, it's 4.84. Now, we do these for each of them. And then at the end, we have to add all of them. Write the sum of them. Sum means like here, you add all of them. You add all these. And then, okay, with this addition, okay, this has to be 0. With this addition, you got this value, and then you will divide it by n. Here the n is the population, the number of the people or the individuals or the subjects in the population. So this is how many? It's 10. So we get the population variation as 2.76. And now you can find the standard deviation. Standard deviation will be equal to square root of 2.75, which is 1.661. So if you want to know what does this mean now about the data, you can say the most values. You can say the most values. You expect most values of the data fall between fall in fall fall in 2 point no 5.8 the mean plus or minus 1.6. So it means they fall in between 5.6 minus 1.6, so which is about 4 point. So if you it's 4.2, and if you add them, it will be 7.4. So they mostly you expect them to fall in this interval 4.2, 7.4 interval. So when you look at them here, 7, 6, and 4. No, it's not 4. 7, 6, 7, 5, 6. Most of the values, as you see, they're in here. So it gives an idea about the spread of the data. Now the sample variance and the standard deviation. So let's do, this is the formula for it. So there are two formulas here for the samples variance. You can do this one. It's like the same, almost same as the population variance, but it's n minus 1 here. This is an important difference. And instead of it, we use also this formula. And this formula is obtained from the first one, but we will not show you how to calculate this one. And the advantage of this part is that you don't have to use the mean here, because you see you don't see any mean here. And when you take the square root of the sample variance, you get standard deviation. So you take the square root of it. You can also write this one here, and you take its square root, and then it will give you standard deviation. Now let's solve this. Let's find the sample variance and the standard deviation of this data. Now we have a sample here, so this is important sample or population. You know the formulas changes. The formulas change. Now sample variance formula is given by this formula. This is the second formula, and then for this one you have to find the sum of the values and the sum of the squares of the values. So to calculate it in an efficient and a good way, without doing any mistake, it's better you write all the values here and then all the squares in a table. I put them, you see this 8 squared, 9 squared, and 10 squared, and 12 squared. Let me tell you, this is 8 squared, this is 9 squared. You're taking the squares of the values, and then you add all of them. So you got the sum of the values, 54, sum of the squares, it's 614. And what is n, by the way? N is 1, 2, 3, 4, 5. So n is 5. We have 5 sample here, 5 samples. So then we have to put all these in here in the formula, and we get the variance. Now, okay, it's here. We get 7.7, and then how do we find the standard deviation? Take the square root of it, it's 277. Now, we have a sample variance formula for the group data. Now, in the group data, we have the frequencies here. This is for the frequencies. And we have the classes, and the XMs are the midpoints of the classes. we have when we have a group data, we have class, we have midpoint, if you remember it. So it's like 1 to 11, so it will be 6, like 12 to, let's say, 22, is it? Yes. For example, you will get, when you add, so you will get 74, the midpoint. Now, this is just an example. Now, from the classes and the midpoints and the frequencies, and you will find these values, and then it will give you, this formula will give you variance, sample variance for group data, and then when you take the square root of it, so it gives you the sample standard deviation for grouped data. Now let's look at this example. So it says the following distribution gives the cost of repair per circuit in Saudi Riyal. And here the class is given to you. These are the classes. And the number of circuits here, it gives the frequencies. You know, in practice, when we give you the question this way, this is easy to see, but in practice, you have to know, you have to decide which one is the frequency, which one is the class. I mean, here in this question, its classes are very easy, and this is the frequencies. Now, the variance, we will find the variance and the standard deviation. So we have to, we are given a grouped data, so we use the variance formula for the group data. And let me write the formula for it. Squared the variance is equal to n times the sum of the products frequency times the midpoint squared minus sum f the frequency times the midpoint squared divided by n times n minus 1. So this is the formula we will use. So in order to find it, we need to find n. Okay, so we need to find n, which is the sum of the frequencies. This is n, and then we need this the sum of the products with the products frequency and the midpoint, and then we need to find the frequency times the sum of the products of f times the midpoint squared. Okay, now the best way to do it is just I'll make a table and do the calculations, carry out the calculations on the table. So midpoints, first we find the midpoints by looking at the classes. Then you know how to find the midpoint. You add these 2 points, and then you add, so it's 0 plus 19 over 2, so which is 9.5, and the rest goes this way. And we multiply after this. We multiply the frequency with the midpoints here, f times xm. So let's look at the products here. It will be 95. So when you multiply them, you got the other numbers here, the other products. And then the next one is like we need frequency times the midpoint squared. So we have to just frequency times the midpoint squared, and then frequency times the midpoint squared, and the rest. Okay, now I will give you just the numbers I found. Now here are the values we got, and then after we got them, we add them. So we need what? We need the sum of the frequencies, sum of the products of the frequency and the midpoints, and the sum of the products of the frequency times the midpoint squares. Now after finding them, we will substitute them in the formula. So let's put them in the formula. Here after substitution, we got the standard deviation as the variance is 315.64, and we take the square root of it, so we got 17.77. Now, another measure of variation is the coefficient of variation. Now, the coefficient of variation is measuring the variability of a data set independent of the unit of measurement. And basically, it's giving the ratio of the standard deviation to the mean, indeed. So then also you can use the coefficient of variation to compare two data sets in different units. For example, one data set is the weight of newborns and the other one might be the length of the adults measured in centimeters, and you can compare the variability of these two data sets. Now let's see its formula. So here is the coefficient variation formula. So this is standing for the coefficient of variation. Now it basically gives the percentage, what percentage of the mean is equal to the standard deviation. So the coefficient of variation is equal to standard deviation over mean times 100%. So you will find a percentage here, or you will write this quotient or ratio as a percentage. And we can write this formula in terms of the sample standard deviation and sample mean and the population mean and the population standard deviation. So you know them, they're same things, but except the one is for the sample, the other is for the population. Now let's see an application of coefficient of variation. A researcher wants to compare students' weights and heights. The average weight of students is 100 kilograms and the standard deviation of the weights is 4. And the average height of the students is 180 centimeters and the standard deviation of the heights is 2.8. Now compare the variation between two variables or two data sets, you can say. So you collected the weights and you collected the heights of the students, and then you check the variability of two data sets. Now, of course, we will calculate the coefficient of variation for each variable. So then you have to look at the standard deviation for the height divided by the mean of the height, so which is 2.8 divided by 180 times the 100%, so it means 1.55%. And we do the same thing for the weight. So if we put the mean and here is the mean and here is the standard deviation, we get 4%. So what does this mean? This means the data set in the heights in the weight is more variable than the height. So it's more variable means like more changing. So the dispersion rate is, so you can say here dispersion rate of the data rate is bigger. So here is the dispersion rate is bigger than the one in the height. So you can say here the weight is more variable or more changing than the height. Now let's look at this question. If a set of data has a mean 25 and the median 15 and the coefficient of variation of 50%, then the value of the variance is what? Okay, let's try to write what is given to us. The mean 25%, the median is 15. Then the coefficient of variation is 50%. Now it's asking the variance. Okay, how can we get the variance here? We have to know the relation between them and the variance. Okay, there is no direct relation between them, but here the key thing is like to see what the coefficient of the variation. If you remember the formula, this is equal to the standard deviation divided by the mean. Now, this is related to this since the standard deviation is uh, the square root of the variance, we can use standard deviation to get the variance. Now, and we know this is 50%, so we can write here this is 50%, so we write it as a ratio, as a fraction. And then what's the mean? Mean is given here, mean is 25. So this has to be 2510. Then you can use this equality and you say standard deviation is now, if you do this cross multiplication, and you will get standard deviation as 12.5. Then what is the variance? So variance is, you can say variance is the standard deviation squared then. So I'm using this one here. And then 12.5 squared is 156.25. So it will be A. Now let's look at another question here. Okay, the other question is, okay, let's see. Compute the variance given the following information. Now, some product are given here, some sums of the products. So here it gives the midpoints. This XM is standing for the midpoints. So N is the sum of the frequencies or the number of the data, 28. So how can you find the variance of the midpoint, the variance of such data? Now the key thing is here, the key information is this midpoint. So if the midpoints are given, so it's a group data, and for the group data we have the variance formula. The variance formula is, indeed, it's equal to n times fx midpoint squares. Sorry, it is f times xm squares minus f times xm squared divided by n times n minus 1. And we will put these values in here. Okay, let's put them in here. Variance is equal to n, which is 28, times f times xm squares, and which is 3,757, and then minus this one, 313 squared divided by 28 times 27. Now, if you use a calculator, you will see it's equal to 9.56. Now let's look at this question here. What is the average of the squares of the distances? Distance each values from the mean. So if you remember, this is the variance, the definition of variance. So find the sample standard deviation for the given data. Now, if you remember, for the sample standard deviation, we have this formula. S squared is equal to, and this is not a group data, so no frequency nor midpoints are here. So we just use the formula for this: n times the sum of the x squares minus the sum of the x squared divided by n times n minus 1. So this will be, s squared will be equal to n, which is 8. 8 times 17,878 minus 332 squared divided by 8 times 7. So if you use a calculator, you will find A. Now let's look at the Lecture 6 worksheet exercises. Before starting the problems, let's remember what we learned. So the measures of variation: range, variance, standard deviation, and coefficient of variation. These are the measures of variation in a data set. So we know standard deviation is equal to the square root of the variance, and standard deviation measures how much in average data deviate from the mean. So this is the meaning. Deviate means gets far from. And then here are the formulas for the variance and standard deviation for the different cases. If we have raw data, if we have population, we have this formula for the variance, and for the sample we have this one, and for the group data we have this formula. And what we learned here is the range. Range is the highest value minus the lowest value, range of the data, and the coefficient of variation is equal to standard deviation divided by the mean times the 100%. So the coefficient of variation measures the variability of the data, okay, of the data with respect to the mean. Now we can start the questions. Which of the following is not a measure of variation? So measures of variations are range, standard deviation, so variance, and coefficient of variation. So when you look at here, you'll see it says it's not a measure of variations. Variance, yes. Range, yes. Standard deviation, yes. But the weighted mean is not a measure of variation. Now, given that the variance for a data set is 3.6, what is the standard deviation? So in order to solve this problem, you have to know this basic fact, which is standard deviation is equal to the square root of the variance. So standard deviation is equal to the square root of 3.6, and which will be about 1.9. So the answer is A. Find the variance for the frequency distribution using the following sums. Now, here you have to pay attention to the terms here. There's a frequency given, and also the midpoints are given here. So that if the midpoints are given and the frequencies are given, so then it means we are dealing with a grouped data. And the variance for the group data is given by this formula. Now we have to use this variance formula for the group data. And in here, we have to substitute these values in the formula. And n, what is n? This is the number of the data values or the number of the frequencies. So this will be 11, so it will be 11 times. And what is this sum? It's 705 minus, and what is this sum? This is 77 squared divided by 11 times 10, and this will be 1,826 over 110, and this becomes 16.6. So the answer is C. For the following frequency distribution, find the range, the variance, and the standard deviation. Now the frequency distribution says here it's a grouped data because of the class limits here. The class limits are given, and then we have to use the formulas for the group data. Now, the first thing is the range. We have to find the range. So what's the range? The range of a data is equal to the highest value minus the lowest value. But this is a group data. We don't know the actual data values, but we know the class limits for the data. So you can choose the lowest one as the first class limit, lower limit. So this is 1. So the highest one is 50. So you got 50 minus 1 for 49. Now, when it comes to the variance, we have to apply the formula for the grouped variance for the grouped data. Now, if you remember, this is the formula for it. So we need the midpoints, the frequency times the midpoint squares, and the frequency times the midpoints. So first we have to find the midpoints. So how do we find the midpoints? If you remember, we add them, divide by 2 the class limits. It will be 5.5 here, 15.5 here. Okay, okay, you can check them. 25.5 and 35.5 and 45.5. Now, then we have to do the product of the frequency and the midpoint. So this has to be 5 times 3, 5 times 5.5, which is 27.5. And I'll write the rest here. You can check yourself. So these are 31. This is 25.5. This is 248.5. And this is 136.5. Okay, now when it comes to this part here, you have to multiply 5 times 5.5 squared. This one here 2 times 15.5 squared. And you can do the rest this way. And okay, I will write them here 151.25. This has to be 480.5. Okay, I will write the rest here. 650.25. 880.21.75 and 6,210.75. So when you add all these here, it will give you 469. So I will write here times xm is equal to 469. And the sum of f times xm squares is equal to 16,314.5. Okay, now let's put them here. This is 18 times. This one here, 16,314.5 minus this one, 469 squared divided by 18 times 17, and which is equal to 240.85. Okay. Then the standard deviation will be here square root of 140 plus 85, and which is approximately 15.5. So this is the standard deviation. Okay, let's look at this question. For the following data set, find the population variance and the population standard deviation. Now, this is a raw data. If the data is given this way, this is raw data. So you have to use the formula for the population variance for the raw data. So if you remember, this is the formula for the variance, population variance. Now, we need to find the mu here, and mu is, we know the mean of the data here, mean of the population. Now, the mean is, if you calculate, it will be 5 plus 7 plus 9 plus 12 plus 15 divided by 5, and which will be 9.6. Now, how can you apply the formula here? So, by the way, this n, the number of the data here, the number of the data values is 5. So, in order to apply this one, write the x values here and write the mu here. The x values are 5, 7, 9, 12, and 15. Then for the mu values, we have 9.6 and 9.6 and 9.6. Same for all data. I mean, the mu is the mean of the data, so it will be same. It's not changing, it's fixed. So now you have to check the square of the difference between the data values and the mean. So this has to be minus 4.6 squared, and this is negative 2.6 squared, and then 0 minus 0.6 squared, and then this will be like 2.4 squared. And if you look at this difference, it has to be something like 5.4 squared. Now, when you calculate and add all of them, you will get 63.2. And okay, now we can put them here. This sum, we got 62.3, 63.2 divided by 5, which is 12.64. This is the variance, the population variance. Now, the population standard deviation is, we know it's always the standard deviation is equal to the square root of the variance, and this will be standard deviation will be equal to square root of 12.64, which is approximately 3.55 or 56. Yeah. Now let's look at this question. It gives a rough data here, and for this rough data we have to find the range, sample variance, and the sample standard deviation and the coefficient of variation. Now let's remember what the range is. This is the highest value minus the lowest value. So this is clearly, all the data is ordered, so the highest value is 31, the lowest one is 8, so it will be 23. And now for the variance, it's a rough data. It says sample variance for the rough data formula. It's this one here. You can use this or the second one. And now in practice, this is more practical, the second one. So we have to list all the x values and the x squares. And let's write here 8, 9, 10, 17, and 19, 24, 20, 24, 28, 29, and 31. And we take the square 64, 81, 100, and 289, and 361, 361, 400, and 576, and it's 784, and then 841, and then 961. So we write, we add all of them and we get the sum. The sum of the x values are 195. The sum of x squared, so this makes this column here. So it is 4,457. You can check with your calculator. And let's put them in here and let's see what it is. So this is equal to n times, what is n? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10. We have to write here 10 times, what is this? It will be 4,457. Then minus 100. This was 195. Sum of this part here, 195 squared, divided by the sample. It's n minus 1. 10 times 9. So if you calculate this one with a calculator, you will see the answer is 70.72. So it will be 72.72. And what is the variance? What's the standard deviation? So it will be equal to square root of 72.72, which is about 8.53. And the coefficient of variation is equal to the standard deviation divided by mean times the percentage. and this will be 8.53 divided by 19.5 times 100%, and this is about this is about 43.7. Okay, you can ask now, how did you get the mean? The mean is 195 divided by 10, by the way. Okay, let's read the question. If the mean of a set of data is 26 and the variance is 18, then what is the coefficient of variation of this data? The coefficient of variation of a data is equal to the standard deviation divided by mean times 100%. So in this case, we need to find the standard deviation. So and mean. So mean is given to us. Mean is 26. And the standard deviation, we know the standard deviation is equal to square root of the variance. So which is equal to square root of 18. Now, which is about like 4 point something, I guess, 4.4. I mean, 4 point maybe 2, I'm not sure. So then let's write the formula here. The formula says it will be equal to 4.2 divided by 26 times 100%. If you do this calculation, it will be equal to B. Which statement about standard deviation is correct? Okay, let's read them. The lower the standard deviation is, the more spread the scores are. The higher the standard deviation, the less spread the score are. And the higher standard deviation, the more spread the score are. And it's a measure of central tendency. Now, for sure, it's not a measure of central tendency. The central tendency is measured by the mean itself, the mode, and median, these values. Now, these are the measures of central tendency, not this, not the, yeah, the standard deviation is not one of them. It's not a central tendency measure. Now, the standard deviation, if you, as you know, the standard deviation is uh, standard deviation gives you the average uh, distance of data values to the mean. So it means like if you have a mean here and if the data, most of the data is spread like this, so most likely the average you will get something like this. So if the standard deviation is low, then the dispersion here or the spread here is small. So standard deviation is small, spread is small. So if standard deviation is big, so then it means the data here is more spread. So you will get your standard deviation higher. Then here, most of the data lies in the standard deviation around the mean. So if it is low, then you will see the scores are not more spread. They're less spread. If it is high, then they're more spread. So then the answer is B. Now, a researcher wants to compare a hexokinase method and glucose exodase method for measuring glucose. So it means there are two methods of measuring glucose, and yeah, we want to compare these methods. The standard out the deviation for hexokinase method is 4.8 and the mean is 120. So it means we did some experiment, we got some data for this method, and from this data we got standard deviation 4.8, the mean is 120. And we got another data set from the Oxidas method, and the standard deviation of this data set is 4 and the mean is 100. So asking which method is more variable. So indeed it's asking like which methods data set is more spread, okay, more variable or changing, okay, more spread around the mean. So in order to calculate this one, we need to use the coefficient of variation. So it's basically measures how much the changing is data is changing around the mean, or how much changing or how much variable is it. So what you have to do is you have to find the coefficient of variation for hexokinase, and you have to find the coefficient of oxidase method. So you write the mean of this one. The mean is, no, the mean is here 120, 4.8 here for hexo, and for oxy we have 4 divided by 100. So you multiply with the percentage, you change it to the percentage, and you'll get this 4% and 4%. So we get the variability of these two data sets are same. So they have the same variability.